Organolithium compounds. This type of organometallic compounds are usually represented as RLi, where R is an alkyl or aryl group. Methyl lithium, ethyl lithium, normal butyl lithium, phenyl lithium, etc. are examples. These organolithium compounds are prepared from corresponding alkyl or aryl halide by reacting with lithium in an inert atmosphere of nitrogen at low temperature. The solvents may be dry ether, benzene, or normal hexane. Organolithium compounds are pyrophoric, that is, they catches fire when exposed to oxygen or air. They also react with carbon dioxide. Hence, organolithium compounds are prepared, stored, and handled under nitrogen atmosphere or argon atmosphere. Methyl lithium can be prepared from methyl iodide by treating with lithium in an atmosphere of nitrogen at minus 10 degrees Celsius. The solvents may be dry ether or benzene or normal hexane. Similarly, ethyl bromide can be converted into ethyl lithium by reacting with lithium metal in an atmosphere of nitrogen at minus 10 degrees Celsius. Normal butyl bromide react with lithium metal in an atmosphere of nitrogen at minus 10 degrees Celsius gives normal butyl lithium and lithium bromide. Bromobenzene react with lithium in an atmosphere of nitrogen at minus 10 degrees Celsius to form phenyl lithium. Organolithium compounds contains highly polar carbon-lithium bond with a negative end on carbon. They are a good source of carbanions. They give nucleophilic substitution reactions with compounds having active hydrogen atom or acidic hydrogen atom like water, alcohol, ammonia, etc. And they also give nucleophilic addition reactions with ethylene epoxide, compounds having carbon oxygen double bond such as aldehydes, ketones, carbon dioxide, etc. Reaction with compounds having acidic hydrogen atom like water, alcohols, ammonia, etc. Or Li react with HOH. Corresponding alkanes are obtained. CH3Li react with water to form methane. This reaction is carried out in an atmosphere of dry nitrogen. CH3CH2Li. Ethyl lithium reacts with methanol to form ethane and lithium methoxide. Normal butyl lithium react with ammonia to form normal butane and lithium amide. These are nucleophilic substitution reactions. In these reactions, organolithium compounds are decomposed into corresponding hydrocarbons. Reaction with ethylene epoxide or ethylene oxide. Similar to Grignard reagent, alkyl lithium reacts with ethylene epoxide in an atmosphere of nitrogen gas in a solvent like benzene or dry ether to form an addition product. This addition product is a lithium alkoxide, which on hydrolysis in acid medium gives corresponding alcohol. For example, methyl lithium can be converted into 1-propanol by reacting with ethylene epoxide in an atmosphere of nitrogen gas benzene medium, followed by hydrolysis in acid medium. Reaction with carbonyl compounds, that is aldehydes and ketones. Organolithium compounds react with aldehydes and ketones in an atmosphere of nitrogen gas in dry ether or benzene medium to form an addition product which on hydrolysis in acid medium gives an alcohol. In this reaction sequence, formaldehyde gives a primary alcohol. Aldehydes other than formaldehyde gives a secondary alcohol. Ketones gives a tertiary alcohol. Thus, primary alcohols, secondary alcohols, and tertiary alcohols can be prepared from organolithium compounds. Organolithium compounds gives an addition product with aldehydes and ketones. For example, formaldehyde. Lithium having delta plus is added to oxygen atom of a carbonyl group. R group having delta minus is added to carbon atom of a carbonyl group. This reaction is carried out in an atmosphere of nitrogen in a dry ether or a benzene medium. The addition product is lithium alkoxide. The addition product on a hydrolysis in an acid medium gives a primary alcohol. OLI bond is decomposed into OH. If aldehydes other than formaldehyde is used, this hydrogen atom will be an alkyl or aryl group. Hence, the final product will be a secondary alcohol. If ketones are used, these two hydrogen atoms will be alkyl or aryl group. Then the final product will be a tertiary alcohol. Thus, primary alcohol, secondary alcohol and tertiary alcohols can be prepared from organolithium compounds like alkyl lithium by treating with a suitable aldehyde or a ketone followed by hydrolysis in an acid medium.